In this lesson, we're going to learn about angle properties in polygons. Now, a polygon is just a shape with many sides, and the first shape I want to look at here is a triangle. Now, in this triangle, we see we have 3 sides, we have 3 angles, and we know from previous lessons that all 3 angles add up to 180 degrees. Now, when we're talking about the angles, we're talking about the interior angles, so the inside angles. A plus B plus C adds up to 180 degrees. But what happens when we increase the number of sides? Well, when we increase the number of sides, we increase the number of angles. But what happens to the sum of our angles? So we've got a table down here where we can organize all of our information. So I've got a triangle, number of sides is 3, number of triangles is 1, and the sum of angle measures is 180 degrees. Let's try a quadrilateral. Now I have a website, Triangles of a Polygon website, that we're going to use to help us. Now we can have irregular shapes where our shapes are all different lengths, or we can have regular shapes where our shapes are all the same length. So in my options here, I can make this a regular polygon, so it's a regular 4-sided shape, or we can make it an irregular one. I'm going to leave it as an irregular one because the properties hold true no matter what the shape is. As we get further along, we'll probably move towards regular shapes just to make lives a little bit easier, but let's see what's going on here. So I have a 4-sided shape. That's my quadrilateral, and you can see we can cut this into 2 triangles. So I've got 2 different triangles sitting here. Let's start filling out our table here. So it's a 4-sided shape, and I've got 2 triangles. But what happens to the sum of the angle measures? Okay, well, I'm going to redraw this up here. So instead of a triangle here with 3 sides, I'm going to have my 4-sided shape. Draw them like we had there. And I'm going to put my triangle A, B, C back in there. But now I have D, E, and F. Well, the sum of the angles in one triangle is 180 degrees, right? So A plus B plus C is 180 degrees. And then the sum of the other angles, D plus E plus F, is also equal to 180 degrees. So when I'm looking at the interior angles of my quadrilateral, so I've got this one plus this one plus this one plus this one, well, you can see that would just be A plus D together there, right? Plus B plus C and F together plus E. Well, that's the same as A plus B plus C plus D plus E plus F. Well, this stuff here, A plus B plus C, that was 180 degrees. And D plus E plus F, that was 180 degrees. That's all coming from, this is coming from here, and this is coming from here. Well, if I add those together, that just gives me 360 degrees. So the sum of the interior angles of a quadrilateral is 360 degrees, or just 2 triangles worth. 2 times 180 degrees. Okay, let's see what happens when we increase the number of sides by 1 more. So this is now a pentagon, which would be a 5-sided shape. Let's go back and increase, so 1 more side. Here's my 5-sided shape, and again we can move this however we want, but it doesn't change however many triangles. You can still see no matter how we move this around, whether we make it a regular one or not. Here, let's make it a regular one. You still have 3 triangles inside. Okay, so 3 triangles inside. So what does that mean for the sum of the angle measures? Well, that would just be 3 times 180 degrees for the same reason. Well, 3 times 180 degrees is 540 degrees. And you can anticipate as we increase the number of sides in our triangle, the number of triangles inside isn't going to increase by 1. So let's make 1 more. So another 6-sided shape, 4 triangles now. I've got 4 now. That means I've got 4 times 180 degrees worth of angles on the inside. That's the sum of my interior angles, and that would give me 720 degrees. We can continue going with our chart, and you can start seeing the pattern. This would be 8, this would be 6, and this would be 1080 degrees. Because for 900, that was 5 times 180 degrees. And for 1080, that's 6 times 180 degrees. Now, we can keep going and make more and more and more. And as you increase the number of sides, you get more and more triangles inside, whether you want to make it a regular shape or not. But why is this useful to us? Well, sometimes we're going to want to figure out what our interior angles are, and sometimes we're going to want to figure out what our exterior angles are. No matter what we're doing, we're going to use these ideas. But to pull out that website and to draw the shape and figure out how many interior triangles I have first, and then figure out, okay, now that I know the triangles, I know I can multiply that by 180 degrees. That's a lot of work. So let's make a conjecture. Let's try to put this all together and write a formula that'll generalize this pattern. I'm going to use n for my number of sides, and I'm going to use s. I know s isn't great, sometimes it looks like 5, but I'm going to use s for the sum. So a conjecture is just a concluding statement about the relationship between the sum of the measures of the interior angles in a polygon and the number of sides in the polygon. So we know that the sum is going to be equal to 180 degrees times the number of triangles, right? But we're not using a value. We're not making a letter or a variable for the number of triangles. We're using it for the number of sides. Well, how does the number of sides relate to the number of triangles? For a triangle with 3 sides, I had 1 triangle. For a quadrilateral with 4 sides, I had 2. And if you look at the relationship, the number of sides is always 2 more than the number of triangles. So if I take this, subtract 2, it would give me the number of triangles. Does that work for all of these? 4 minus 2? Does that give me 2? Yeah. If I jump down here, 8 minus 2? Yeah, that gives me 6. So in general, the number of triangles is going to be equal to n, our number of sides, subtract 2. So if I take 180 degrees, multiply it by the number of triangles, or n minus 2, that would give me the sum of the interior angles in my polygon. Okay, well, let's try this for a 12-sided shape. So how would that work? So I'm trying to figure out the sum, so that would be s, 180 degrees, multiplied by n, which is the number of sides, 12, minus 2. Well, that would be 10 triangles inside. So the sum of the interior angles would be 180 degrees times 10 would be 1800 degrees. And that would be the sum of the interior angles in a polygon with 12 sides. All right, how does this relate to exterior angles? Because I had already mentioned that that's where we're going with this. Let's take a look at the next page. So it says determine the sum of the measure of the exterior angles in this shape. So here we can see we've got a quadrilateral, a 4-sided shape, and we can see the inside angles are all 90 degrees. Well, if they're sitting along a straight line, we know that those two angles are going to add up to 180 degrees. So if those are supplementary and that's 90 degrees, we can safely say that this will be 90 degrees, this will be 90 degrees, and so on all the way around, because we know about supplementary angles. Now, how does that relate to the exterior angles of any polygon? Well, in this example, each exterior angle has a measure of 90 degrees. So if we add up all the exterior angles, 90 plus 90 plus 90 plus 90, that gives us 360 degrees. All right, now let's see if this is going to hold for the exterior angles of this pentagon. So let's take a look. Here's our pentagon. we can see the interior angles A, B, C, D, E, and we can figure out for the interior angles what each angle should be, assuming this is a regular pentagon, using our properties from our table, right? We know that the sum of the interior angles is going to be 180 degrees multiplied by the number of sides minus 2. Well, in this pentagon, the number of the number of sides is 5, so n minus 2, that would be s is equal to 180 degrees times 5 minus 2, or 180 degrees times 3, and we've already done this on the other side. So the sum of the interior angles is 540 degrees. Now, even if we didn't know what the interior angles were here, A plus B plus C plus D plus E, if we don't know what the inside ones are, because it doesn't say this is a regular pentagon, we would still know that the two angles together would give us 180 degrees. So even if I don't know W, I know that it would be equal to 180 degrees minus B, because they're supplementary. And that would hold for all of these angles. So I'm going to go ahead and write that all out. Now let's add up all of these exterior angles. W plus X plus Y plus Z plus V. Now I'm going to substitute, instead of having V, I'm going to put 180 minus A. Instead of W, I'm going to have 180 minus B. And I'm going to substitute that in and see where we're going with this. Let's collect all the like terms. So if I have my sum here, I've got 180, right? Add all those 180s up, and then add up all the letters. So if I add up all the 180s, 1, 2, 3, 4, 5 times 180, that would be 900 degrees, minus A, minus B, minus C, minus D, minus E. So simplified. Let's take the negative out. Sum would be 900 degrees minus A plus B plus C plus D plus E. Well, over here, we said that the sum of the interior angles, A plus B plus C plus D plus E, is equal to 540 degrees. So I'm going to just replace this 540 degrees with this, since they're equal the same thing, and we can see that the sum of the exterior angles is going to be 900 degrees minus the sum of the interior angles, which is 540 degrees. Go ahead and punch that in your calculators, and you can see that once again we get 360 degrees. Now, if we did this again with another polygon, and then again with another polygon, we will see that no matter how many interior angles we have, the sum of the exterior angles is always going to be 360 degrees. Very much like the complete turn of a circle, this will always hold. The sum of the exterior angles will always be 360 degrees. Let's take a look at some examples and use these properties. So it says here, outdoor furniture and structures like gazebos sometimes use a regular hexagon in their building plan. Determine the measure of each interior angle for a regular hexagon. Well, a regular hexagon means that all of these lengths are the exact same size. So by putting a tick mark on there, I'm indicating that these are all the exact same size. So we've got a hexagon, meaning we have 6 sides. So the sum of the interior angles would be 180 degrees times n minus 2, where n is the number of sides. Here I have 180 degrees then times 6 minus 2. 180 degrees times 4, or 720 degrees. Now that's for all of the interior angles. They're asking for each interior angle. Well, if we take the 720 degrees, which is all of the interior angles all added up, and divide that by 6, we can get what each angle is equal to. So 720 degrees divided by 6 would give us that each angle is 120 degrees. Let's take a look at B. Determine the measure of each interior angle for a regular 15-sided polygon. And remember, again, the regular means all of these are the exact same length. So put those tick marks on there to indicate for yourself and for whoever's looking at your work, if I'm marking it, that you understand that those are exactly the same sizes. So we're using the same formula, 180 degrees times n minus 2, but this time for a 15-sided shape. 15 minus 2, which is 13. 13 times 180 degrees, that would give me 2,340 degrees. Again, they want to know the measure of each interior angle, so I'm going to take that, 2,340 degrees, divided by 15, to give me 156 degrees for each angle. C says the sum of the interior angles of a polygon is 3,960 degrees. How many sides in the polygon? So this is a little bit different. Using the same formula, but they're giving me the sum. So starting at a different place. Sum is equal to 180 degrees times n minus 2. And they're giving me that the sum is 3,960 degrees. How do I solve for n? Well, the first thing I'm going to do is get rid of that 180 degrees. So if I divide through by 180 on both sides, that helps get rid of that. And I'm left with 22 is equal to n minus 2. Well, all we have left to do now is to get that n by itself by adding 2 to both sides. Add 2 to both sides here. That's a 0 pair. And I've got that 24 is equal to n. And that means that the polygon has 24 sides. The very last example here, polygon has 13 sides, so we're just using the formula again. S is equal to 180 degrees times n minus 2. So we've got 180 degrees times 13 minus 2, 180 degrees times 11. So the sum of the interior angles is 1,980 degrees. The hardest part is just knowing what they're asking for and how to use this formula over and over again. Thanks for joining me today.